Back again for part 2 of exercise 7E. Try to full screen this bad boy. There we go. Alright, let's get to it. Example 24, we're going to be using a rule to find the value of an investment after a certain amount of years. We've got this example, and then we've got one more TI Inspire calculator example after this. Let's say that there's a rule for the value of an investment, and this can be shown as to get V of n is equal to 1.09 to the power of n times 10,000. So there's a few pieces of information that we can extract and observe here. The first question is asking what is the amount of money that's initially invested. This can be determined by this value here. So initial amount, the initial V of 0 is equal to $10,000. The second part is asking for the annual interest rate for the investment. So how much is this going up by? Now a lot of students fall into this mistake of writing 1.09, where that does indicate a growth. That 1.09 is a multiplicative factor. What this is specifically asking for is an interest rate, a percentage. So this interest rate is actually equal to 9%. Now, this is obvious because we can see that there is a 1.09, but if you really struggled of trying to figure out what this value is, you can recall that our big R value, and I'll put aside this big R value is 1 plus R over 100. And what this is saying is 1.09 is equal to 1 plus R over 100. Solve for R. Tell me what this is. If you were to punch this into your calculator, it will spit out R is equal to 9. But here we can see, because we're so familiar with R values, that R is equal to 9%. Question C. C is saying that we are looking for the value of the investment after 4 years, correct to the nearest cent. So in other words, we are trying to find out what V of 4 is. And all this is grabbing our multiplicative factor, such a tongue twister to say, putting this to the power of 4 and multiplying this by the initial amount of 10,000. So we're taking 1.09 and multiplying it to 10,000 4 times. Just popping my answers up here. When done correctly, this will give you a value and amount of 14115.82. Question D, find the amount of interest earned over the 4 years corrected 2 decimal places. So one question, and it's like very similar in the actual, I guess, words themselves. One is looking for an investment amount, which is here, and one is asking for the amount of interest that has gone into the account over the first 4 years. So what this is asking for is, if I started off with $10,000 and I'm now gone to $14,000, 115.82, how much extra money is that? Well, it's just the difference between these two. It's just the difference of 14115.82 and 10,000. Question E, what we are looking for is the amount of interest earned in the 4th year, corrected to the nearest cent. Now, question D and question E look eerily similar in terms of we're dealing with the interest amount, we're dealing with 4 years, and they pretty much look identical. Again, I've seen students fall into the trap of thinking that there is a double up within the question, so they'll just write whatever this answer is. But what this is specifically saying is find the amount of interest earned just in the 4th year. So we've gone from V3, we're at the end of the 3rd year, and some time has elapsed, 1 year. And from there, we have got a V4 amount. So obviously V3 has a particular amount, and then V4 has got a particular amount. And what it's asking for is what is that difference between V3 and V4? Because that will tell me how much interest was earned within that 4th year, from the start to the end. So we're going to find what V3 is, and we're going to find out what V4 is. So when done correctly, my phone just keeps, with my solutions, keeps rocking. Here we go. When you find V3, so this is 1.09 to the power 3 times 10,000, you will get, just indicated here, 12950. 0.29. Now we already know what V4 is. We found this out. So we're going to find the difference between V4 and a V3. This will equate to $1,165.53. That's how much interest has been earned within the 4th year. Last question, determine if the investor has doubled their money within 10 years. So I'm just going to write F up here. So I'm a bit crammed for space. Okay. So F is saying, yo, have we got more than $20,000 for V of 10? So when you work out V of 10, 1.09 to the power of 10 times 10,000, this will yield the amount of $23,673.64. Therefore, yes, it has. It has doubled. That would be fine with. Yes. So that's example 24. Last example, for example 25, as you can tell, I'm it's running pretty late at the time. 11:08. And I still got another video to make after this. This is the last example. We're going to use our TI Inspire calculators to solve a geometric growth and decay problem. So in here we can see 3 values, which is, it's not looking promising. So there's a lot that we can have to try to interpret and try to extract from this. Industrial Weaving Company purchased a new loom at a cost of $56,000. It has an estimated value of $15,000 after 10 years of operation. If the value of the loom is depreciated using a reducer balance method, what is the annual rate of depreciation? So it's saying it starts off at this amount, goes down to this amount after 10 years, and it has a depreciating reducing balance method. So it's going down by a percentage, and it's not a flat rate, it's a reducing balance method. So it's different, depreciates the same way that we see when a certain amount is going down exponentially. We're going to write our answer correct to one decimal place. Setup is going to be your best friend. So let's write our rule template. To get V of n, we're going to get r, multiplicative factor, big R, to the power of n, and we're going to multiply this by our initial amount. But we run into a bit of a problem because big R is actually formulated from this 1 minus small r over 100 to the power of n times v0. So yes, this is a multiplicative factor, but how do we get this multiplicative factor? By getting 1 and subtracting the rate. And what we don't know is what this rate amount is. Usually it's given to us within the question, but this time we're trying to solve for it. But what we need in order to solve for it are all the other variables that are involved. So how we got to a final amount, how many iterations it took, and what our initial amount. And coincidentally, these happen to be the 3 values that are shown here. So in other words, I'm getting to $15,000. This is my end result after I apply a percentage rate, which I don't know. This happens 10 times from an initial amount of $56,000. Okay, so we've found out pieces of information within the question and we've plugged it into the template that's here. A lot of people will go and write this particular formula down, get a result or get an R value, and they end up getting like 12.3%. And then they put this in and they say, oh yeah, I got my big R, it's 12.3. And I say, hold on, this isn't increasing by 12.3. It's not being multiplied by 12.3. What the hell's going on? And they forget this important step. So be very careful. We're going to use the solve function. So what we're going to do is once we put this into a calculator, we're going to smack a solve at the front, open bracket, put all of this information in with a comma and then the letter R. So what this is saying, and if you read this in like syntax format, the calculator is looking at this, it's scanning through this whole equation and it's saying, you want me to solve for R? I've noticed there is an R here. Sweet, let's solve for this. And when done so correctly, you will get a specific R amount of 12.3%. So in other words, this is decreasing on average of 12.3% per year. At the 10th year, it will drop down to $15,000. Here are the questions that you need to tackle for exercise 7E, page 371. Go ahead and please ensure that you finish the questions for 7D, which can be found on the handouts. If not, you can check Google Classroom. And then also exercise 7E. Just to ensure that you know where the particular notes are, when you go into your Google Classroom, 7D and 7E will be put up. Obviously, this is scheduled for 9 o'clock the next day, so on the 29th, this will be open for you. And then within the stream, hopefully, we'll be a bit redundant now, but there will be access to the videos, part 1 and this video, part 2. Best of luck, guys, with these questions. I will be at home mining the fort, making sure Rio is okay. And hopefully I'll see you guys on Wednesday. And if you're at TAFE or university or hacking school, whatever, I'll see you guys on Thursday. Bye.